Course 3, Industrial Processing, Resource Efficiency and Waste Management in Food Systems, Raw Materials and Waste Management. This module introduces the principles of raw material control within industrial food supply chains, focusing on how sourcing decisions, raw material quality, and supply chain dynamics affect processing efficiency, food safety, waste generation, and sustainability performance. It examines industrial supply chain structures, upstream-downstream dependencies, and sourcing models, with particular attention to traceability, regulatory compliance, and supply risk management in the European context. The content addresses practical approaches for evaluating raw material usability and value, including physical, chemical, functional, and economic criteria, and explores strategic sourcing and inventory control methods to improve resource efficiency and resilience. Material flow analysis is presented as a key tool for mapping inputs and outputs, identifying loss points, and quantifying food loss and waste in processing operations. Best practices in raw material handling, hygienic design, process standardization, and operator training are discussed alongside strategies to reduce avoidable waste and manage unavoidable byproducts. The module also introduces waste valorization pathways and circular economy principles, including energy and water-efficient technologies and cross-sector reuse options. Digital solutions for waste monitoring and inventory optimization are highlighted as enablers of data-driven decision-making and continuous improvement. After completion, learners will be able to apply best practices for managing raw materials and minimizing waste during processing. Food processing plants operate with large volumes of raw materials, and waste generation is unavoidable. However, how these materials are managed strongly affects efficiency, food safety, and environmental performance. Within the European Union, food processing represents a significant contribution to food waste, making waste reduction at this stage especially important. Effective raw material and waste management is therefore not only a sustainability goal, but also a key driver of operational performance and cost control. Food waste is a major global and European challenge. Roughly 1/3 of food produced worldwide is lost or wasted, and within the European Union alone, tens of millions of tons of food waste are generated each year. Food manufacturing contributes a significant portion of this total. Waste at the processing stage represents not only lost food, but also wasted energy, labor, and disposal costs, making reduction efforts particularly impactful. Food waste reduction is strongly embedded in European policy. Under Sustainable Development Goal 12.3, the EU aims to have food waste by 2030. Member states are required to monitor food waste levels across the supply chain, including processing. At the same time, strict food safety and hygiene regulations apply. This regulatory context makes systematic raw material and waste management an operational necessity rather than an optional initiative. Material flow analysis, or MFA, is a key tool used to understand and reduce waste in food processing. It is based on the principle that matter is conserved, meaning that all inputs must appear as products, byproducts, waste, or stock changes. By systematically tracking these flows, MFA makes inefficiencies and hidden losses visible, providing a solid basis for targeted waste reduction measures. The first step in material flow analysis is mapping raw material inputs and outputs. This involves creating a process flow diagram that shows each production step from raw material reception to final product. All inputs, such as ingredients and water, and all outputs, including products, byproducts, and waste streams, are recorded. This visual representation provides transparency and supports systematic analysis of material use. Mass balance is a central concept in material flow analysis. It requires that all material inputs equal the sum of outputs, waste, and any changes in inventory. When discrepancies appear, they indicate unmeasured losses or inefficiencies. Accurate mass balance calculations allow processors to quantify yields and identify where improvements are needed to reduce waste. Reliable data collection is essential for effective material flow analysis. Input data are typically obtained from purchasing and receiving records, while outputs are measured through production and packaging systems. Waste data may require direct weighing or audits. Increasingly, inline sensors and automated systems support accurate data collection, enabling more precise identification of waste and loss points. Once material flows are mapped, the next step is identifying loss points. These are stages in the process where materials leave the intended product flow and become waste. Losses may occur through trimming, spillage, or quality rejections, and some may be hidden. Identifying these points allows processors to focus improvement efforts where they will have the greatest impact. At the start of processing, raw materials are frequently inspected, sorted, and trimmed. This generates waste such as peels, bones, or rejected portions. While some of this waste is unavoidable, especially inedible parts, excessive trimming driven by cosmetic standards or inefficient equipment can increase losses. Optimizing trimming operations helps reduce unnecessary waste while maintaining product quality. During processing, materials can be lost through spillage, leakage, or adhesion to equipment surfaces. Liquids may spill during pumping, powders may be lost as dust, and viscous products can remain stuck inside equipment. Poor equipment design or maintenance increases these losses. Regular calibration, proper design, and good housekeeping practices help minimize these avoidable wastes. Thank you.